Alright guys, so this is probably the first new thing that we've looked at in probability, but it's combining two ideas that we've looked at previously. So we're looking at trio diagrams and the multiplication rule, which is written down here. So the best way to go through this is just look at an example. So in a particular office, we have 60% of employees who are female and 40% who are male. Of the female employees, we have 80% who say they exercise regularly, while 70% of males say they exercise regularly. So first step is you're asked to construct a tree diagram using this information. Okay, so you want to make a nice wide branch because you know you're going to go further out. So female, and we've got male. So we know, sorry, actually, rub that out. And again, sorry about that, guys. So probability of selecting a female and a male. So probability of female, and you write the probability on the branch here. So 0.6 and then 0.4. So total probability means that these are complementary events. They're either male or female in this exercise. 0.6 plus 0.4 is 1. Okay. Now, once you've selected as a female, there is an 80% chance, given you're female, that you exercise, given you are female. Okay. So you've got a 0.8, which means there's a 0.2% chance that you don't exercise when you are female in this office. Okay. From that, you can still draw the information, same with men. So we have 0.7% of men. So given they're a man, there's a 70% chance that they exercise, and there's a 30% chance that given a man that they don't exercise. Cool. Now, using the rules of probability here, the multiplication rule, the probability of F and E. So selecting someone who's female and likes to exercise is you multiply along the branch. So you've got a 0.6% chance of selecting someone who's male, and then you've got times by 0.8. So this would be in the calculator section, guys. So 0.6 times by 0.8 equals 0.48. So you just multiply on the branches. So have a go at filling out the rest of this, and see how you go. I'll pause for a second, have a crack, and I'll keep going to see if you got it right. Okay, so the next one will be the probability of a female and someone who doesn't exercise. So someone who's female and doesn't exercise would be 0.6 again, times by 0.2. Using your calculator is 0.12. Okay, and then you've got probability of someone who is male and who exercises is equal to 0.4 times by 0.7, which equals 0.28. And then the probability of someone who is male who doesn't exercise, so E dash, so dash there is equal to 0.4 again times by 0.3. Just going along the branches, which would be 0.4 times 0.3 equals 0.12. Now, you can test that you're right here by simply adding up. 0.48 plus 0.12 is 0.6, plus 0.28 is 0.88, plus 0.12. That's 1 all up. So that's the total probability. So these are all the possible outcomes. You're either in this exercise, you're a male or female, and you either like or do not like to exercise. If you add them all together, you're going to end up with 1. So that was part A. And then you don't always need, for some questions, you don't always need to draw out this full diagram because you can just use this rule up here. But what the trick is reading the question carefully. So find the probability of a man not exercising regularly. Okay? So the trick here is to read the question carefully. This isn't asking to find someone who is a man and doesn't exercise. It's just asking the probability of finding a man not exercising regularly. Okay? Probability of a man not exercising regularly is this one here. Okay? They've got a 30% chance because it's not saying overall or finding probability of random selecting a man, someone who is a man and doesn't like to exercise. You've already selected a man, so this is the given probability. Not exercising given he's a man. Okay? So the wording of the question is important. Now the next one will show you the difference. Find the probability of randomly selecting someone who is a man and exercises regularly. So that is someone who is a man and exercises regularly, which is probability of A given B, or probability of M of E given M, times by the probability of M, which is 0.4 times 0.7, which is 0.28. And then the last one, find the probability of selecting someone who is female and does not exercise regularly. Someone who is female, who does not exercise regularly, would be and would be 0.12. So reading along the branches, 0.6 times 0.2, which is 0.12. So the key takeaways, guys, is set up your diagram clearly, read the question very carefully, and don't forget this probability rule here. Okay? If you can do that, you should not have a problem with this exercise. Good luck. Post any questions on Teams.